Hello everyone and welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 in November time zone 0. Question number 9 relating to topic 4 bonding and structure for standard level, asking for the stuff about bond strength of covalent bond. Let's see. Number 9, which compound has the shortest C2O bond? So that means here, first of all, student must be realizing that the idea, what's meant by shortest means strongest, right? Because the bond length, which is going to be a really critical criteria that we look for in terms of indicating a bond strength. The shorter the bond, the stronger the bond it is, right? Makes sense? So that's why now we should be choosing the strongest CO bond. And the strongest here also means the bond order that is going to be highest bond order. Bond order simply implies the idea that if it is going to be a single bond, that is bond order of 1, double bond order of 2, and triple bond, the bond order of 3. So here we should be choosing a triple bond if there is, would then be shorter than a double bond, shorter than a single bond. Makes sense, right? Because the higher the bond order means the greater the interaction between the two bonded atoms, and so this will leading to the distance between them to be shorter. Makes sense, right? So that simply means for this question, we should be first sketching all the bonding pattern. And this bonding pattern, we also called it the Lewis structure. So that's one by one, right? For A, basically this is going to be an aldehyde. If student recognize it, for this ending CHO, we call it an aldehyde homologous series. And basically this one should be sketched in this way, right? CH3 and then C double bond O with a lone pair and a hydrogen. Right, so in this case we can see that the CO bonding area is going to be a bond order 2, a double bond. Makes sense, right? Yeah, let's see. For B, basically carbon monoxide, which is going to be a really special case in terms of the bonding area. If students have realized it in terms of topic 4, this is a really special example of illustrating a dative covalent bond, or we can say coordinate bond, right? Within this case, actually, how come a carbon can form an interaction with oxygen 1-to-1? That's all because one of the bonds within them is going to be a dative. Yeah, that's all because carbon need 4 bonds, we know that, but an oxygen in fact just need a double bond in order to fulfill the octet structure. But then how come the carbon can then be fulfilled? It's all because here they found a triple bond in which one of the bond is a dative. So that's why one of the lone pair of the oxygen is just directly bonded and shared with the carbon with no participation within this dative covalent bond, plus the 2 normal double bonds. So if the 2 normal bonds together as a double bond, so all together, so the Lewis structure remaining 2 lone pairs for each of them. Yeah, so this is the Lewis structure regarding the carbon monoxide, and you can see here the bond order, which is basically a triple bond. So that's a bond order 3, as because of the nature of a dative covalent bond is the same as a normal covalent bond. So that's why dative or not doesn't really matter in terms of the strength. But then we know this is going to be a triple situation, right? Yeah, so for C, I think C is not difficult because this is a really classic example for illustrating the linear structure in terms of the shape deduction area for your textbook. So that should be a carbon in terms of having 2 sides, each double bond with the 2 adjacent oxygen. So that's the bond order for the CO area, obviously 2, right? Yeah, so finally for D is going to be also an organic compound in which a kind of special functional group that students are better to know the nature of this functional group. So that is going to be a ether. So with a C2H5 one side, single bond O, single bond with another C2H5. Yeah, or we can call it a ethoxyethane. For this compound, a new functional group called ether, but then now we are not dealing with the chemistry behind this, but then just the CO bond. So only first order, right? Just a single bond. So that's why the shortest bond should go with the highest bond order. So in this case, we should choose the one with the highest number. So obviously the answer goes to B.